All right, today's discussion is going to revolve around perimeter and area relationships. So just a reminder, perimeter is the distance around the outside of an object, and the easiest way to think of it is that you could measure perimeter with a string, and area, the best way to think about it is you could measure it with pieces of paper or tiles, little squares of some kind. Okay, so just a reminder of those things. So perimeter is the length or distance around the outside of an object. Area is the space covered by the object. So if you imagine your string going around the outside, that's perimeter. And the space covered is all of these little squares. It could be tiles or pieces of paper. They're not the same. Okay, the following square has a perimeter of. Well, if we started on the edge and we walked all the way around all four sides, we would have 4 groups of 9. So we would have 9 plus 9 plus 9 plus 9. Okay, so we would have a perimeter of 36 centimeters. Okay, for area, if I wanted to count up these, there are 9 rows that have 9 squares in them. Okay, so a shortcut for this would be a multiplication case. So we would have 9 times 9. So the area here would be 81. If you want to, take a moment and count the squares. You'll see there are 81 centimeters squared. So please note the distinction between these. Area is measured in little squares. Perimeter is measured in just centimeters. Okay, so they have different types of units. That's really, really important. Okay, so when we look at this, we can see that some of this stuff is repetitive and that we could probably use some sort of formula or faster way to solve. So if we look at a square and a rectangle, they're both in the same family. So the area of a rectangle or square, and all of these mean the same thing. Length times height, width times width. They're just linear dimensions on the outside. It doesn't matter. Okay, side by side, that's another way of looking at it. The names are not that important. However, when we get to a rectangle, because the two dimensions are different, that's the definition of a rectangle, we say length times width. And we have to denote that each one of those values is different. If we had a square, because both dimensions would be the same, we can just say it's s times s, or s squared. Those are the sides multiplied by itself. Okay, so there's two formulas for rectangles and squares. Hopefully you've seen them before. In fact, I know you have, because we've been doing area model for multiplication from the start of the year. So let's carry on to some other shapes. We have triangles. So an area of a triangle is just half of a rectangle. And if you think of that as half of a rectangle, you should be able to see that all 3 of these ones, whether it's base times height divided by 2, 1/2 base times height, 1/2 times base times height in a bracket, those are all the same formula. Okay, so this base and this height, that's the area of the rectangle piece. And then the half is saying we're only taking half of it. Okay, now one important designation to note, base and height always meet at 90 degrees. Okay, so this little 90 degrees right here, this would be the height, this would be the base, they meet at 90 degrees. A lot of people make mistakes when they see this. Let's go down here and see this line right here. They call that the height. That is not the height. Because it's at an angle and not at 90 degrees to the base, that is not the height. Okay, the height is the red line going up through the middle and meeting the base at 90 degrees. So this is the height. This is the height. And this one, even though it's outside of the triangle, is still the height. So if you multiplied this height by this base and divided by 2, you would get the area of this strange shaped triangle. Okay, so it would still work. Area of a parallelogram, and we'll put all of these into action later. Most of these are fairly straightforward, I hope. Area of a parallelogram is the base times the height. not the end length. So we are not using this dimension. Okay, we're using the vertical dimension, okay, which is really important to note. So I'm going to get rid of that. Okay, and then if you look down here, the area of a parallelogram has the exact same equation as the area of a rectangle. It's base times height. And why is that possible? Because we could take this little piece on the end, trim it off, and rotate it. Oops, sorry, I don't even need to rotate it. And just slide it down here, and you'll see we get the base times the height, and it makes a rectangle. Trapezoid, okay, another quadrilateral. A is the average length times the height. So this piece right here, the average, okay, if you took the top dimension and the bottom dimension, add them together and divide by 2, that would be the average. So if you have a quiz mark of 6 out of 10 and a quiz mark of 8 out of 10, if you add those two together, you'd have 14, divide by 2, you'd get 7. That would be your average. So this piece right here, this is the average of those top values, the A and the B terms. So when we're looking at a formula here, we would have, this would be our A value, and this would be our B value. Okay, and again, take a look at these expressions. All of these are the same thing. A plus B all over 2 times H, 1/2 out front, the whole, everything A plus B and times H all over 2. These are all the exact same formula, just rearranged slightly. Okay, so if we were looking at the area of this trapezoid here, if we counted squares, 1, 2, 3, 4, 5 on the top. So A is 5, 1, 2, 3, 4, 5, 6, 7, 8, 9 on the bottom. So the average of 5 plus 9 divided by 2, and it has a height of 1, 2, 3, 4, 5. So this would be 5 plus 9 is 14, divided by 2 is 7, times 5, we would find there are 35 little squares. Let's say they're centimeters just for argument's sake. So if you wanted to just do a quick check, could grab this little red shape, and I think if we do this, and then flip left to right, kind of fits in there. Okay, and then if we looked at that rectangle, that's a 5 by 7 rectangle. 5 times 7 would be 35. There's the same answer we got. Okay, now the good news for you is that you will never have to memorize these formulas. You should know the square, the rectangle, and the triangle, but the others we shouldn't have to memorize. Maybe circle, you'll just find it handy to have that in your pocket. These will be available to you from a formula standpoint, so you should make yourself look at this, go over it, do you understand where the numbers come or the letters come from, and then that will always be provided for you. So let's actually do a problem. Oh, sorry, let's do one more. We haven't done circle yet. So the area of a circle, and the circle is the only one that has a strange value in it. It has this pi value, which is sort of an odd value. Okay, it's a irrational transcendental number, I think is the fancy term. Basically, it's a non-terminating, non-repeating decimal. Okay, it just keeps going on and on and on. It has a value of 3.1415927, and on it goes. We're happy with 3.14 for any of our calculations. Okay, and it's a product of this being a curved or round shape. Okay, so a couple of important terms that go with a circle. The radius goes from the center to the outside of the circle, and the diameter goes through the center and goes from edge to edge, but the diameter is just 2 times the radius. Okay, so that's an important distinction to have. The area of the circle is pi r squared, and then the circumference, and the circumference is just a fancy word for perimeter. Okay, so the distance around the outside of a circle, okay, is called circumference. So it comes in 2 forms. You could have 2 pi r. Remember that 2 times pi is just the same thing as d. Either one of those will work just fine. Okay, and hopefully this is all review. You've seen most of this before, I hope. Okay, so there's a couple of questions to try in the appendix at the back of the book. Thanks for tuning in.